Okay, so this section is about using law of cosine. So what am I going to be able to do? I can use law of cosines on a non-right triangle. Okay, so law of cosines again is a non-right triangle formula, because if you have a right triangle, you either use the Pythagorean theorem directly or you use sine, cosine, and tangent directly. So I can use law of cosine. So there's two main formulas we're dealing with here. Okay. First one's law of sines. Law of sines is set up two fractions and solve. Law of sines is fairly significantly easier than law of cosines. So if possible, you always want to kind of start with law of sines if you can. All right. So here we go. We're not doing the top at all here because we kind of did that in the thing, and also it's area, so we don't care. All right, law of cosines. When do I use law of cosines? Essentially, when you can't use the law of sines. Pretty much what that means is you have no pair. So there is no pair to build your fractions. So you don't have an angle on the opposite side. When that happens, you're stuck with law of cosines, okay? So law of cosines, you have three sides, side, 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 or a side, the angle, and the side. So one of those three patterns, all right? When I look at these are essentially the same exact formula over here. It's just the three different setups depending on how the triangle is labeled, okay? Can anyone tell me, what does it look like if I don't have the cosine piece attached to it? What formula does that actually look like? Right, so it looks like Pythagorean theorem, okay? So it is the Pythagorean theorem, except your triangle's not right. Who can tell me what is cosine of 90 degrees? So if you're using Pythagorean theorem with the law of cosines,
0.
So if cosine of 90 is 0, what happens to all these pieces? And now it's just the Pythagorean theorem, okay? So the Pythagorean theorem is essentially the special case where you have a right triangle, and so your cosine of 90 is 0, so you don't need it, right? So this is non-right, which means we have we have three angles and none of them are 90. So that means we have more formula in our lives, okay? So on this one, what you need, how I remember this formula. So memory ideas, okay? Essentially, on one side, if I have C, then on the opposite side of the equation, I have cosine of C. So essentially, there's that, and in the middle, I have an equal sign, okay? So that's kind of how I remember, is that's how you set it up. So whatever angle you're putting on the one side, on the right side, the across the equal sign has to be the opposite side. So C, cosine of C, B, cosine of B, A, cosine of A. All right? So that's kind of my thoughts on how you can remember how to set this up. All right? All right, so let's do a couple of problems. So first problem. Here I am. It's saying find AB. There's AB. That is side C. That is side B. That is side A. So 26 is side A. Side B is 29. Side C, I don't know. Angle C is 94 degrees. Please note, I cannot use law of sines because I do not have a given pair. I have to be able to have a fraction with no variables for law of sines. So the only angle I know is 94, and unfortunately I don't know the side, so I cannot set up a fraction where I have everything known, okay? So when that happens, then I'm stuck with law of cosines. So my setup, I'm looking for, here's my pair. There's side C, there's angle C, okay? So on the first side, I'm going to have C squared. And on the other side, I'm going to have cosine of C. C squared equals A squared plus B squared minus 2AB. So I remember it's got to be, so I use side C and it's all this on its own, and then it's A squared B squared minus 2AB. That's the formula, okay? I've just rewritten the formula. C squared is what I don't know. What do I put in for A, everyone? What number is A? Okay, so 26 squared. What is B? 29 squared minus 2 times 26 times 29 times cosine of what? 94. I want you to notice that this looks horrible, but if I look at this, are there any variables over here? Does that mean I need to solve anything or do any actual algebra? No, I need to pull out my handy dandy awesome calculator tool and plug it in. Okay, 40.28 miles. That is your final. Did you forget to square root it? Okay. Verify this answer, okay? Once you've done that answer, I would like you to do number 6. See what you got. Number 6, and you've done it correctly. Your answer should have been that side A is 25.79 kilometers. I think I checked most people, and I think most people got this correctly. So that's your answer, okay? All right, so this one is the easy one. This one is the easier one because essentially you just have to set it up right, and you just have to be careful with plugging it in. You don't have to really do any solving. It's really just evaluation. So it kind of looks ugly, but there's not a whole lot of processing involved besides the setup, because after that, use this awesome thing called a calculator to do your work. Okay, the other type is a lot harder, and that is the type where we have 3 sides and no angles, okay? So we're on number 7. Number 7. Okay, and it's saying I want A. So I want this. Okay, what side is opposite to A? 28. So that's my pair. So my formula is then A squared equals B squared plus C squared minus 2BC cosine of A. Okay? All right. A squared, oops, sorry, 28 squared equals 17 squared plus 15 squared minus 2 times 17 times 15 times cosine of A. The challenge here is that you're actually solving for cosine of A, and you actually do have to do algebra on this. Here is the problem that occurs, okay? be careful, because what I see people doing a lot, this is the most common error, is you basically take this whole thing here and add it together and make it a single number. That is incorrect. Can anyone tell me why you can't actually put all those numbers together like that? Nope, it is not. Does anyone see it? Yes, because what is happening right here in between 2, 17, and 15 is multiplication. You cannot take numbers that are being multiplied and add them together. So a strategy to help avoid that is when you do these kind of problems, your next step would be to add a set of parentheses right there, because that is a single quantity, all right? So now I'm going to evaluate what I can evaluate. So what I'm going to get here is 784 equals 514 plus negative 510 cosine A. Okay, now I've essentially, what I've done is pretty much combined everything I can combine without doing anything else. The numbers are going to be large because you're squaring everything. What's my next step? What's the next thing I should do?
Subtract 514.
Exactly. So I subtract 514 and I get, yes, that is correct too. You do need to solve it, but I'd like to know how that happens. That would be helpful. And now since this is gone off of this side, I've now got rid of it. Oh, you're right. 270. Okay. Negative 510 cosine of A. How do I move the 510 over to the other side? Divide it. Correct. It doesn't feel like people are actually listening because they're too busy talking. Okay, the last step. I actually need to get rid of cosine off of here. How do you take, so you do what? Correct. So A equals the inverse cosine of 270 over negative 510. I'm too lazy to calculate that separately, so that's what I'm putting in my calculator. Let's see what I get. Okay. A is 121.97 degrees. Students, okay, your last task here before we end today. So that's, verify that's what you're getting on inverse cosine. Actually do the inverse cosine, make sure.